It is not a hard thing to get people interested in springs because springs are like, hello, they're crystal blue gems in the green woods. It's absolutely like this fantastic thing that you can't believe they're real until you see them. I am so passionate about this because wherever you live in North and Central Florida, you are connected to the springs. We live here in the land of 1,000 springs. My name is Kelly Keys, and I'm the Communication Director of the Wakulla Springs Lab at FSU. Wakulla Springs is one of the largest freshwater springs in the entire world. It's an international geological heritage site, meaning it is on par with Yosemite, with the Yellowstone geysers. Geologically speaking, it's a big deal.
Wakulla Springs is this very large and beautiful spring that has an iconic role in our community. It's important in a number of ways. I think there's the obvious economic impact of it in terms of tourism and recreational activities. It has a second level of importance because of this insight that it gives us into our groundwater. My name is Joel Trexler, and I'm the director of FSU's Coastal and Marine Laboratory, and I'm a professor in the Department of Biological Sciences. To me, the Wakulla Springs is like a little porthole to look into what's happening under us all the time, and if we didn't have the Wakulla Springs, we wouldn't really be very aware of it. You can walk up to this spring and you can see that groundwater bubbling right up, and you can see how the condition of that water changes through the year. That's where our groundwater comes from, our drinking water.
The aquifer supplies all the water we use in Tallahassee, in the whole region. 90% of North Florida's drinking water is supplied from the aquifer. And so what we shower with and cook with and use in agriculture, that water is coming from the aquifer. And so that is what supplies Florida's, not just Wakulla Springs, but Florida Springs in general.
All of Florida is called a karst landscape, so we're basically on limestone, which is generally very porous.
This limestone dissolves relatively easily in rainwater, and that rainwater creates these little pockets, and then over time some of those get really big, and some of those get so big they become the cave system, literally the piping underneath our feet that is kind of like the highway bringing water to the springs. Sometimes those caverns reach really close to the surface, and there's just a little tiny bit of material in between them and the surface, and sometimes they collapse. And so those become sinkholes. And so some of those sinkholes are direct, we call them windows to the aquifer.
It's a very interesting portal into our groundwater system. Having that insight, that little viewport right into the groundwater that we have at Wakulla Springs, to me, that is the most direct way that if we're paying attention, we can appreciate how we're interacting with our environment. There's actually many different sort of springs and sinkholes, so water going down into the ground, water coming back out of the ground, many places like that around in this area that are all interconnected under the ground by these cave systems.
Before our project, scientists put dyes into some of these sinkholes in the region. Many have shown that the dye comes out at Wakulla Spring. Down the way in our region, water is flowing south, and so we know that many of these sinkholes in the region are really directly connected to Wakulla Spring.
They've used dye tracing studies and also other chemical analyses of water, and divers actually just going and swimming in caves and tracking that using remarkable technology to create maps of the caves, all of which have created one of the most well-mapped, longest flooded cave system in the world, I say. And yet there's still more to know.
I never thought I'd find my own caves that were unexplored, but actually had an opportunity to find a couple places that no one had seen before, and had the experience of what they call laying line, because we put a guideline in the cave wherever we go. And when you're doing that in an unexplored cave, it's really exciting because you get to see a part of the planet that no one's been in. My name is Chris Brown. I'm currently on the board of directors of the Friends of Wakulla Springs State Park, which is a citizen support organization that likes to educate and explain and help support the park in any way we can. My first discovery of an unexplored cave was actually a sinkhole in someone's yard. Someone mentioned that a friend of his had a sinkhole in their yard, and they used to swim in it a lot, but nobody had ever been to the bottom of it. And so I thought, well, it's time someone did go to the bottom of it and see if there's a hole there, because often a sinkhole is a window into the aquifer. Sometimes they're plugged, but sometimes there's a cave. We got down to about 100 feet down and started to level out and shined our light into the darkness and couldn't see any walls. I mean, the light just went out into this vast space, and we looked at each other and went, uh-oh, we just found a cave. The fun of unexplored places is that it's hard to find parts of the planet that haven't been explored before anymore. And especially when they're in your own neighborhood, you can drive up to them and go exploring out of the back of your car or your truck. I mean, it's just really amazing to be able to do that. And that's what it's like in Florida and in a karst region like this, where there's aquifer access all around us.
McCullough Springs is this very interesting little portal into our groundwater system. Water picks up elements from the geological context that it flows through. And so that is the origins of this idea of a fingerprint, because it'll pick up different chemical constituents that we can measure, and they're going to be distinctive of that geography, that geological context, that place that it came through. And I think that we're also adding this idea of a biological fingerprint. We're looking at molecular data, which is basically DNA sequences. We're focusing on DNA from bacteria and algae. We're using a method that gives us really deep insight into the diversity of different kinds of bacteria that might be present in the water. And there's lots of reason to think that the microbial communities in waters, they make a fingerprint as well. They're very distinct and tied to the chemistry and the conditions at a particular site. We're looking for evidence that that molecular fingerprint could also be used to trace the sources of water out the spring.
There's a really good intersection between the recreational community and the science community. There are fresh discoveries going on all the time. And the science is really important, because if we're going to manage the aquifer systems properly, and we have to, then we really have to know how they work. So the research right now is incredibly important, and the funding up till now has been really slim.
Our funding, it was 1 year of funding, and so that had to play a role in thinking about how do we use our time and our resources and our opportunity to produce a product that has a lasting contribution.
So if we can keep interest up and awareness up, then I think the powers that be will continue to help out with funding, because it's essential.
None of us can accomplish things if we don't have income. We have to have funding to do the work, to support people while they're doing scientific activities.
Any financial support for the work that's being done is extremely important. The urgency, I think, is really on us now to understand and really know what's going on. Once you understand how the aquifers work and what we have, then you have to become an advocate for it too. You just have to, because they're so vulnerable. And we're using it up like crazy. We're using the freshwater at an incredible rate right now.
We as humans, I would hope, would want to know about the secrets we haven't yet uncovered. So it's so important to keep studying the springs, because there are many questions that we haven't answered.
Studying the environment and gathering data on it is our best way to make informed decisions, and I think that ties very directly into land use and land management decisions.
The sort of simple way to think about protecting and caring for a spring is start at the spring and then look upstream. Upstream through the pipe, literally the piping that the spring comes out of, the underground, underwater cave system, and also the surface water. If you look upstream of that, those are the places that you want to think about what we humans are doing to the land and doing to the water that is going to impact the springs downstream. My favorite feedback I've ever gotten is that a student was speaking to his instructor, and he said, you know, when it rains on campus, I look at the rain and I think, where is that little raindrop guy headed to? He's headed to Wakulla Springs. And that is the goal, is to connect for people that nature is us. Nature, even when you're standing on the pavement in town, you're connected to nature.